All right, good morning. I'm planning to do biweekly contest 77 from last Saturday. So here we go. Okay, open these guys up. Choop, 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 choop. Count prefix is given string. Word. Prefix of S. Just do a linear scan of all of them. Okay, so let's do this. Oops. Using the S goes vector string. Okay, 7:59 a.m. A for auto T and A. Let's see. Do this. Int k equals s dot size. Turn the count in the end. Oops, count to 0. Okay, so if t equals t dot size is equal to, wait, no. Yeah, t dot size is less than or equal to sk, and t equals s dot subster 0 to t dot size. Count plus equals that. Okay, that should do it, I think. Uh-oh, unknown error. What? That's strange. Unknown error? What the hell is this? I've never seen that before. Okay, whatever. K equals s dot length of s for t and a. If the length of t is less than or equal to k and t is equal to s dot substring from 0 to length of t, right? So count plus equals int return count to 0 initially. Oops. Int like that. 3, and the other one's 2. Looks good. Okay, so I don't know what the heck's going on with C++ then, right? So what the heck is this? Unknown error? What? Oh, what the heck is this? It's fine. Okay, you just go back and come back and it works. Okay, whatever. Computers. Okay, let's jam on this in the other languages here real quick and then get going. Okay, so k is the s dot length for let t of a if t dot length is less than or equal to k, and I don't know if we need an intermediate, right? This is fine, just do this. S dot length and t is equal to s dot subster 0 to t dot length. Right, and then count plus equals number that. Turn the count in the end. Count is equal to 0. Looks good. JavaScript, Python 3, Kotlin, for T and A. If T dot length is less than or equal to S dot length, and T is equal to S dot subster 0 to T dot length, count plus equals 1, otherwise 0. count 0. Turn that in the end here. Turn count. Okay. Uh-oh. Substring. Okay. Let's see. Rest. tn a.iter. Let mutable count equals 0. Turn the count in the end. Count plus equals if t.length is less than or equal to s.length, and t is equal to s sub 0 to t.length. String from that guy. One, otherwise 0. Uh-oh. Card by bound introduces call and how its size known at compile time. Ah, okay. Still not that great at Rust. Let's see. Let mute j equals 0. Well, j is less than t dot length, and s of j equals t sub. Wait, hold on. Chars s dot chars dot nth j equals t dot chars nth j plus j if j equals t dot length, count plus equals 1. Oops, j plus equals 1. Unknown error. Not the first time I've seen that. It must be an online judge issue within LeetCode itself. I just tried again, it works fine. That's strange. Okay, let's stick these in here. A few solutions. Now solutions which use the substring function. And we could create other more complicated solutions, I suppose, using like grab and carp or something like that, probably. But this is good enough, whatever. I want to get to the third and fourth question with enough time to actually solve them. Okay, let me copy and paste these here and we'll get going. Okay, Rust is super verbose. I have a lot of room for improvement there. Okay, C++. Boop. Python 3. JavaScript. I wonder if I can do one-liners too. This might kind of be cool. Let's see. Can probably filter and reduce a. Let's see. A.map. Or A.filter dot size is what we want. T dot it dot length less than or equal to s dot length, and it equals s dot substr 0 it dot length size. Yeah, okay, that looks good. something like that. Oh, I stepped substring. Okay, that's cool. And then we can change it into lambda, make it look a little bit shorter. Okay, this guy equals this closure, which returns this guy. Okay. Oh, missing missing squiggling around that guy. Okay, that's cool. Let's do this. Those solutions. Do some one-liners. Uh-oh. One-liner solutions. Kotlin. JavaScript. Python 3. Oops. Okay, let's do this. JavaScript. Let count prefixes equals a dot filter t dot length, oops, less than or equal to s dot length, and t is equal to s dot subster 0 t dot length. Return the length of that filtered array. Uh-oh. T dot length is less than or equal to s dot length, and oops, t equals subster. That's good. Stick that there. Okay, Python 3. Class solution. Prefixes. Someone let's do this. Equals lambda as, and then we're going to return the length of the array, which is filtered. T for T and A if length of T is less than or equal to the length of S, and T is equal to S 0 until the length of T. That was good. Okay, cool. Stick that there. Okay, let's post this and move on. All right, and whatever, nothing too fancy. Okay, minimum average difference. Okay, so we're looking for the absolute difference of the first one and the last one. So this one seems to be begging for prefix sums or some kind of pre-calculation. So then we have to recalculate them. All right, we'll do a linear scan from left to right, right to left, come up with the absolute differences. Maximum, or we want the minimum average difference. The average difference of index 0 is 2 divided by 1 minus what? Average difference, index I is absolute difference between the average of the first I plus 1 elements. So if it's the first I plus 1 elements, I is 0, it's the first. What? Both averages should be rounded down to the nearest integer. Zero, 1, 2, 3. Minimum average difference. 2 plus 5 plus 3 plus 9. 6, 3, 0, 1, 2, 3. Divided by 4 minus. Okay, so it's the first element, 2, has cardinality 1, minus 1, 2, 3, 4, 5. Okay, the last elements, okay. Okay, so I just need the prefix sums of the first half, and then the prefix sums of the second half, and then do a linear scan to find the best solution. Yeah, we can do it in C++. Calculate prefix sums to reduce asymptotic bounds to avoid TLE. Right. First half, or it's not necessarily a half, but of the pivot, or pivot index 0.I inclusive minus, divided by the cardinality of the first half minus, I should take the absolute difference. Second half of pivot index I plus 1 dot dot n minus 1 inclusive. All right, divided by the cardinality of that too. Cardinality of the second half. Okay, so that's the game plan, right? Game plan. Okay, here we go. Best equals 189 plus 7, return best. Prefix sums will be VI. Just do S is cool, right? N equals A dot size. S will be of size n plus 1. Let's do it from right to left. For auto I is n minus 1. 0 is less than or equal to I. I. S sub I equals A sub I plus S sub I plus 1. It's a recurrence relation for I to J non-inclusive prefix sums. Then do for auto I 0. I is less than n plus I. Our candidate will equal the prefix sums of the first half, which is from S sub I to S sub I, S sub 0, right, to S sub I plus 1, so I is not inclusive, would be the first portion. Let's do this as A is this guy, B will be the second half, which is S sub I plus 1 inclusive to S sub N. So that's the right half. This is divided by the cardinality of that. Divided by the cardinality is 0 to I plus 1. And then the cardinality of the other portion, see if we have, this is our array. That's example 1. 0, 1, 2, 3, 4, 5, 6. Okay, so n equals 6. N is over here. And then I equals 0. Then we divide it by I plus 1. And the penalty is over here. There's 5 over here. So it's n minus 1 minus I divided by n minus 1 minus I for B. And then our candidate equals the absolute difference between A and B. Best is the minimum of itself and this candidate. Okay. Uh-oh, divide by 0, that's not cool. Okay, so what happened? Divide by 0. Must be here, right? When I is n minus 1, that is 0. It needs to be plus 1 then, right? N minus I. Oh, wait a sec. Did I have the parentheses wrong? I minus. So when I is 0, there's 1 less over there. But when I is, right, when I is 0, n minus 1 is 5. There's 5 over here, so that's right. But then I is, let's say I is 5, then this should be equal to 1, right? So n minus 1 minus 5 equals 0. See, when I is 1, then we have 2 here to I inclusive. It should be n minus that, right? N minus I plus 1. N minus I plus 1. Isn't that the same thing as n minus 1 minus I? It should equal 1 when we get here, isn't it? Hold on, my music going here. Disconnect. Okay. Yeah, so I want to equal the right-hand side to equal 1 here, 1 here, 2 here, 3 here, 4 here, 5 here. Oh, we don't go all the way up to that. So the right-hand side has to be I plus 1, right? So we don't go all the way up there. Okay, that makes sense. So n minus 1 minus I is correct, but we just don't go all the way up to the right-hand side for this calculation, right? That makes sense. 0, okay, that is not correct. Index 3 should be 0. Best is the oh, okay. It's okay. So we don't keep track of best. We want to keep track of the best index as well. Best I equals -1 if best is less than the candidate. Candidate is less than best. Best exceeds the candidate. Best equals candidate. Best I equals I. Okay. Should be good. No way. Oh, best I is what I want to return. Best index. Right, which should be 3. Okay, cool. And then the other one should be 0. Uh-oh. 0. Okay, so when there's only 1, then it has to be 0, I suppose, right? Just default it to 0 then. Uh-oh. Okay, so the wrong answer. Input's 420, output is 0, but we expect 2. 0, 1, 2. 2 is something I don't even consider. When it's 5, then what is it? There is no second half. Okay, so there's no second half, but I do need to consider up to it. Let's see. I plus 1 is less than n, otherwise 0. Oh, dang. Whoop. Okay, so we need to consider A and B as long longs. Let's do this. Long long using VL as vector LL. VL is this guy. Prefix sums. Long long. Okay, didn't crash. Yay. Okay, so it's a little bit tricky in that the rightmost candidate is 0 when it's no longer existent. So that's an edge case. And then the long long, that's kind of an edge case. Okay. Let's jam on this real quick. A few solutions, we'll post here. Okay, and basically we'll take right, so we use the art of dynamic programming. I use a prefix sums to to avoid TLA. Right, I guess pre-process the input via prefix sums to avoid TLA. That looks cool. Kotlin. JavaScript. Python 3. Rest. C++. Okay. That's the best index based on the pivot of the first and last half. All right, cool. Yeah, whatever. Okay, so S equals the length of A. Time this H28 AM. I think it should take like 5 minutes or less. Turn the best index. So best equals int 29 7, best I equals 0. For the corner case of a single element. 0 times, or let's just do this, equals a colon s subsys dot append 0 and 4 in range n minus 1 to minus 1 non-inclusive by minus 1 s sub I equals a sub I plus s sub I plus 1 right to left for I to j non-inclusive, and then to so for I in range n, a is equal to the prefix sums from 0 to I plus 1. I plus 1 is non-inclusive. B equals S sub I plus 1 S sub n if I plus 1 is less than n, otherwise it's 0. And then our candidate is the absolute difference between A and B. And if best exceeds the candidate, then best equals the candidate, and the best index equals I. Okay. That does not look right. 2, 0, 0. Something's not quite right here. Oh, we need to divide it, right? So we need to divide it by the cardinality of evenly divided by the cardinality of I plus 1, and then evenly divide this by the cardinality of the second half, which is n minus 1 minus I. Okay, that looks right. Uh-oh. Okay, that looks legit. Okay, cool. Okay, 8:31. Okay, so 8:31, yeah. About 3 minutes. That's cool, right? All right, stick you there. JavaScript, 31 a.m. to, it should take like 2 or 3 minutes. Okay, so let n equals a dot length. Let s equals array I plus 1 fill zeros. Or let I equal n minus 1 down to 0. I base of I plus s of I plus 1. Or let I equal 0. And all right, so trying to find our best, which is the minimum difference. 7 I 0. Turn best index at the end, and then let A equals S sub 0. S sub 0 to S sub I plus 1 equals if, let's see, I plus 1 is less than n, S sub I plus 1 minus S sub n, and this needs to be divided by evenly, or the lower bound, right? So math.floor, this divided by I plus 1. This one will be math.floor. This guy divided by n minus I, 1 minus I, otherwise 0. If best exceeds the candidate, let candidate equals the absolute difference between the first and second half based on the pivot I. Best equals candidate, and then best I equals I. Looks good. Okay, 8:31, 8:33. 2 minutes. That's cool. Okay. All right, let's do this in Kotlin. Okay, so var n equals a dot size, var s equals int array. actually want this to be a long array, right? Because Kotlin's kind of like JavaScript. It's gonna be a hard time. 0 for I in n minus 1 down to 0. S sub I, a sub I plus s sub I plus 1. All right, then we're going to have bar best I equals a pair. This will be an integer, 29 plus 7 dot 2 int, and then 0, return the best index at the end. And then for I and 0 until n, find the pivot. So var A is the first half from s sub 0 minus s sub I plus 1, since I is non-inclusive. That'll be divided by I plus 1, B equals, if I plus 1 is less than n, we're going to do s sub I plus 1 to n, non-inclusive, divided by n minus 1 minus I, otherwise 0. Our candidate, math.abs, C minus B, and then if best exceeds the candidate, best equals the candidate, and best index equals I. Best equals candidate long, int is expected, candidate dot to int, candidate dot to int. Here's okay. From a long to an integer. Looks good. It's cool. Okay, and then let's do this in Rust and get on to Q3. That's when things get a little bit more interesting. Okay. Let n equals a length. Let s equals vector. Fill it with 0, size n plus 1, and then as usize for I in 0 till n non-inclusive. Or actually, we want to go in reverse order. Okay. S sub I equals a sub I plus s sub I plus 1. Okay, then for I in 0 till n, non-inclusive, our best I equals 29 plus 7. Now let's just do this. 1, 2, 3, 4, 5, 6, 7, 8. That guy, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and then 0. Return the best index at the end, and then let a equals s sub 0 minus s sub I plus 1 divided by I plus 1. Let b equals, if I plus 1 is less than n, to s sub I plus 1 minus s sub n divided by n minus 1 minus I, otherwise 0. Let candidate equals a minus b dot abs if best exceeds the candidate, best is equal to candidate, best index equals I. Okay, something like that. Oops, var should be let. Oh, where did that? Oh, there it is. Let. Oops, need to be mutable. Mute. Found usize by 32 as usize. turn it to usize so I don't get the integer overflow. Method not found in usize. Oh, that's not cool. Okay. I64, I suppose. As I64. I don't know if this works or not. As I64. Abs as I32. Expected I35 found usize as I32. Unknown error. Cannot borrow S as immutable. It's not declared mutable. Yay. Okay, looks good. Uh-oh, unknown error. Okay. Alrighty. Thank you, Russ, for giving me a hard time. Okay, yeah, these are okay, right? Preprocess the input via prefix sums to void TLE, right? Okay, so and perform a linear scan for each I pivot index candidate. Right, to find the best. That's good enough. It's good. Okay, cool. Let's get on to Q3 and 4, right? So I have 47 minutes, about halfway through. Count unguarded cells in the grid. Return the number of unoccupied cells that are not guarded. G and a W is a wall, guard. 7. There's 7 that you can't see. Guard can look in each direction. Okay. Mark what's been seen by each guard as they go outwards and a BFS. And then look at what's not been seen. Right? I think that makes sense. Let's do this. Right. Perform BFS from right, starting from each guard position, and keep track of what's at each cell IJ seen, and return the count of unseen cells. Right? This doesn't count the guards / walls, right? These are actually right, empty candidate cells, right? Okay, so that's the game plan. Okay, and let's do the implementation, 8:43, and then that'd be cool to get this done real quick and have a sufficient amount of time for Q4. Using BI equals miniatures, BI, vector BI, okay. Okay, there's our guards and our walls, VBI, and G, VBI, and W. Right, so these are passing by reference. Okay, to M and N. Okay, let's do this using Q and then using a pair of integers for our cell coordinates. This is a Q, a pair. Okay, Q. A pair will be all of the guard cells, right? Okay, so just initialize a Q, right? For auto each pair in G, auto ij equals tie pairs 0, pairs 1. Okay, and then I want to basically stick this in the queue for each pair. Q dot push ij, then keep track of what's been seen. Unordered set of strings, or actually let's do this using scene. We'll do just an unordered map. This works. The default for unordered map is false for a bool. Okay, scene. Okay, and then mark these as scene, what's been in the queue, and then we have to create a, yeah, that works right. Scene, so I, so j equals true. Okay, and then let's do this. Return m times n, right? All the cells possible minus all the guards minus w.size minus scene.size. It's what's left over via deductive reasoning. Okay, and then just outward expansion from each of these guards, as long as it's not in a wall. Using blocked, blocked or no? Or in a wall, how about wall's cool, right? Do the same thing. So O of 1 lookups per wall. Okay, and then for auto each pair in the wall, do auto ij equals tie. Same thing as the other guy. And then we'll do wall sub I sub j equals true. Okay. And do this first, do the walls, then do the guards, and then from the guards do while q dot size, and we'll bump up the q size every time we can expand outwards, left, right, up and down from the guards. All right, so k equals q dot size, 1k chunk at a time per depth. Okay, so then we'll go and take each ij with adjacent uv. So pairs, I guess. Or we just do vector pairs. Cool. We're not going to use it any other place. Right? A vector of pair up, right, down, left. If 0, oops, 0 is less than or equal to u, and u is less than m, and 0, these are in the bounds basically. 0 is less than or equal to v, and v is less than n. And not wall, u is v, and q.push uv, and then scene sub uv equals true. Okay, that looks about right. On the code, 14 is not correct. 14 is not correct. Should be what's seen minus the cardinality G minus the cardinality W, right? Should be all the ones that have not been seen. Okay. All right. So 8:43 to 8:49. So about 6 minutes. Or it's for incorrect solution. Okay. So start debugging and fixing. Let's see what's been seen. G.size. Yeah, that's weird. Okay, well, all right. Copy scene that begin, scene that end. Oh, actually, let's do this. Okay, let's just print out the grid, right? Let's just do a quadratic scan of the grid, and then just print each cell, right? J columns, out I, J, J equals the scene sub I sub J, or a wall, or a guard. A guard is it? Oh, guard. Oh, I need to keep track of the guards too. Guards are kind of like walls, right? You run into guards, guards run into each other. Yeah, the guards are seen. Yeah. Oh, okay. Wait, hold on. So the guards are seen. Each guard that's seen. We don't want to track the guard size then. Scene should include the guards. Scene, wall sub I sub J. Okay, let's see what this output produces. See what's going on. Where I'm going wrong. 0, 0 is seen. Okay, what's not seen then? I guess 0, 1, 2. 0, 2 should not be seen. 0, 2, somehow that is seen. 0, 1 is not seen though. Wall. There. Let's do this. Let's just do this. Scene sub I sub J equals true. Does that work? Just mark the walls as seen, right? Just super simplify it. Right? Walls are seen, guards are seen. All the cells the guards are able to traverse are seen. Then why am I coming up with such a large number then? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So there's 24 cells total. Here, let's print out the scene that size, so I don't have to go through all these. See out scene that. Wait, we know scene that size. It's 24. Oh, okay, that's why I can't use scene that size. Okay, aha. That makes sense then. Okay, so for everyone seen, I can decrement the count. How's that sound? Let's do that. Okay, and count equals m times n, and return the count in the end. Okay, so then it's not really relevant for walls, right? Minus count for each of these. Minus count. Okay. Oh no. Okay, so that's 0. Oh man, she's everything. What? She. Oh, it can only be up, down, left, right from each guard. So I'm doing a buffer search that looks at everything. Oops. Okay, so for each guard, just shoot out, right? That'll be the game plan. Okay, so that's I see. Okay, so maybe that's where the difficulty will arise. I run into TLE. If you shoot out each guard, you have to shoot out each guard in a way that makes sense. Okay, I see. We can direction. The naive implementation, will it TLE? What if this one hits that one that goes down? Still want to go to the left, I guess. Not seen. Okay, yeah, a little bit different. Oops. Okay. Oops. Okay, so this solution visits all cells, not just the rows, columns. Each guard is within. Okay, so let's fix this up. 56. 56 a.m. Okay. Walk them outwards. Don't do this whole queue deal. Walk each of these things outwards. Walk from IJ. Base expand across, I guess. Expand. Expand. Capture everything by reference. J. Okay, so if we expand it, then we want to go as far up as we can, as far right as we can, left as we can. It's not a wall, it's not seen, then we can go that way. All right, so for auto UV, in vector appear, up, right, down, left. Rest is this. These should be a deltas up, right, down, left, DI, DJ. Auto U equals I plus DI. B equals J plus DJ. Okay, so if U is less than 0, or U is equal to M, or V is less than 0, or V equals N, or scene sub U sub V, or wall U sub V. Let's see, continue. Trying to break out of this loop. Otherwise, if it's cool, then we'll say scene sub U sub V. It's not a wall, right? Or it is a wall. Okay, C sub U V is true. Let's count. Up, right, down, left, expand. Okay, so that looks cool. And IJ. Okay. 12 is not right. Ugh. What the heck? Mark it what's not seen, I suppose. Okay, debug this thing. Okay, so 856 to 901. 5 minutes. Or wrong solution. Time to debug. Or auto J. If it's not a wall, and it's not seen, okay, this one J. Not a wall, not seen. There's 12 of them. 0 and 2 is correct. Okay, 0, 2 is right. 0, 0, 1, 2, 3, 4, and 5. 0, 4, 0, 5. 0, 2, 0, 3. So 0, 3 is not correct then. This guard should go up after this guard has gone that way. So that's a problem. So I need to keep track of what's been seen as well as what's been seen in what direction. All right, so here's the problem, right? I'm tracking which cells IJ have been seen, but I'm not taking into account the direction. So this causes us to be unable to skip over, right? Already seen cells from different guards in different directions. Okay, so yeah, that's a problem. So scene UV W fine and whatever. Let's do this. Right, this is not correct. We can do let's add a W onto this guy. Map. Okay, so WB seen on the direction as well. W, the art direction. This is pretty ugly. Okay, scene. Each direction needs to be set to true. Total hack. But I think that should work, right? You can skip over it. Okay. Uh-oh. Oops, does not mean to be a pair, it needs to be a tuple. This should work, right? Vector of tuples. Uh-oh, scene IJ. Oh, this is just my debug print. 11. Oh, I'm looking for 7. I'm getting 11. Ay, ay, ay. Okay. Can't. Oh. Okay, yeah, so obviously, I this is the point, right? The point in this contest question in which I'm just throwing stuff on the wall to see what sticks. And it makes sense to reassess, right? KISS, keep it super simple. Right, so it's been seen in which direction, and it's giving me a hard time. Right, can I keep it simpler? What's an easier way? I wonder if I can do dynamic programming, like down and to the right and then up and to the left. Right. I wonder if that DP makes sense here. We can pre-process the input from top left to bottom right, then from bottom right to top left. And in that case, then as long as it's a guard cell, right? Mark these ones as a guard, down to the right of that guard, up and to the left of the guard. That would make this solution more simple. I think we can try it. Let's give it a shot. Let's see how much time we have left in the contest. We have 21 minutes. Okay. We might be able to get this one in time. Let's see. Just a completely different game plan. Okay, so game plan, switch. I'm not writing the, the naive brute force BFS. I guess it's not necessarily brute force, but not writing the naive BFS solution correctly. What if we break the problem down into optimal substructures per cell? Zombie cells, right? Each guard can infect adjacent cells. Non-wall, non-guard. I'm pretty sure we can do this from, right? Just to say, yeah. Top left to bottom right. Bottom right to top left. Let's give this a shot. Okay. Do this. Let's just do using sets, unordered set of strings, and we can encode those with a hash. J string stream. Right, so stick that in the key and then use that as a set of what's been set of guards. Set of wall. Guards can be expanded, and then walls are where you get stuck. For each pair wall. J equals type, it's the pair. K equals hash, or just call it key, right? It's cool, whatever. Key, EIJ. Okay, and then wall dot insert and key. So each pair of the guards. Same thing, right? INJ and then guard. Insert key IJ. So we can do then return m times n minus wall dot size minus guard dot size. All those are expanded. Guard. So the advantage of this is I can just use the cardinality of the set without having to have a unordered map of unordered map. But then the downside is you have to use the key to create a string from the pair. My TLA. Let's see. Okay. So in the guard. Right, okay, so top left to the bottom right. M J J. Okay. Down and to the right. Right. There's nothing down to the right of the last one though. Wait, there is something down though. Right down on the last column. Okay. So yeah, that's one. We have it down. Listen M. It's not a guard, but just continue, right? K equals key IJ. If guard that find the key is not one of the guards, just continue. otherwise, if it is a guard and I+1 is less than n, and wall.find I+1j. Let's do this. We don't need an intermediary, right? If it's not a guard, then we continue. If down is not a wall, then we'll add it to the guard, right? Guard. Insert key I+1j. Similarly, if j+1 is less than n and not part of the wall, j+1, guard insert key I j+1. Okay, so that should do down to the right, and then we want to go back up and to the left. Right, so same thing. So for auto, I is n minus 1. Less than I minus I. For auto j is n minus 1 down to 0. If, if guard dot find key I j, guard dot end is not a guard, and we will continue. Right, going up and to the left, it's not a guard, we'll continue. Left. Okay, so if I minus 1 is less than or equal to, it's greater than 0, greater than or equal to 0, and wall.find I minus 1j, wall.end, see, right, it's not a wall. Okay, right, it's available, it's not a wall, and guard insert key I minus 1j, and if 0 is less than or equal to j minus 1, and that adjacent cell is not part of the wall, guard, I can insert the key I j minus 1. Okay, something like that. Let's see what happens. Well, let's size guard dot size m times n minus I. Nope. Find key. 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 And I am using these twice, so I could put these in an intermediary variable to speed up optimization. Okay. 0. Uh-oh. Semicolon, not a comma. 0. Oh my goodness. Ah, this doesn't work either, right? Because, dang it. Ah, man, I'm not really thinking too straight. Okay, this one is surprisingly tricky in a convoluted way, right? The way I'm doing this, I'm also consuming these values too, so it's not quite right. Wow, okay. Okay, I'm toast. Making silly choices and mistakes, right? I have to do get some mental clarity and upsolve probably tomorrow. And just try again tomorrow morning. So the challenge I found is just like hopping over these existing things, and I think BFS should work. You just gotta be able to skip up somehow. You just have to avoid TLE and come up with a better game plan. So, all right, 10 minutes left in the contest, but I'm toast. I tried this a handful of times. It's not really working that well. I should have been able to do this. I feel like this might be the way I'll explore again, is doing the BFS expansion with the direction as part of what's been seen, and maybe just clean that up so the logic's not just such a hack, like a quick and dirty hack. All right, oops. Again, I'm visiting all cells by accident. This, right? This is not part of the problem statement, right? Solving the wrong problem. Okay, catch you next time. I'll solve this later.